tools. And this is one approach how I learn things. And I put a little firework in here because I think also the feedback thing is a really big thing that really helped me to advance my knowledge. I learned things that I didn't learn necessarily from the papers itself. There were some special cases that I didn't know about, and by feedback, people helped me a lot during this process. And you can also, in data science, approach this differently. So before I said, you can take a new, if you want to learn a tool or algorithm, you can implement it. But in data science also, what it is about really is answering questions about your data or showing that you're creative, that you are a problem solver, not that you are just a coder or something like that. So go out there and find some interesting data sets, or there are, I think I have later some links where you can find interesting data sets, or if you have an interesting question that you want to answer, go out there, look for data sets, or maybe ask for data sets and just work on them, explore them, write down your insights, and then also share them and get some feedback. And just for the completion, another firework here. But so that was more about how I learned, and I found also this nice plot here in
just tap the screen.
All right. Looks better. Okay. Yeah, so here this nice plot shows also basically a basic workflow of data science process that you start with a question. If you're a business, you want to solve a particular question, maybe for example, the new ad that we put in there, is it really helpful or not? And then you explore your data, you collect data, you explore the data, you build predictive models, then you interpret the models and you communicate it. And I will also say, for example, I'm working on a project where I'm working with experimental biologists, and the communication part is really important. I can build whatever models, but to them they are black boxes. So I should also be able to explain to them what do the models mean, why do they work, and what do the results mean. And usually this involves, because my collaborators are not machine learning people, they want to have it simple. I mean, they don't have the background, they don't want to have complex neural networks presented to them. They want maybe a simple decision tree where I can say, okay, I can go down the decision tree together and with them and explain them, these are the decisions, and if we make these decisions, we get a good result or we get a bad result. And I found this is a really nice graphic summarizing a typical data science workflow. And maybe also talking a little bit about my own projects that I just found some really old projects I was working on when I started like 3 or 4 years ago. So the first thing I did is I really picked a project that I was personally interested in when I came here to the US. I'm from Germany, so everyone in Germany is excited about soccer. And yeah, so what I did is basically, do you know about daily fantasy sports? So daily fantasy sports, how this basically works is there are like betting portals or stuff like that, and you make predictions on players who you think are playing well in the real life. And then you buy these players, and when they're performing well, you make money basically if you rank highly in these things. And I used this as a driving tool. I was interested in soccer, but I also wanted to learn, for example, certain coding parts, data cleaning, data acquisition. And that was a really nice, just one example how I got into all these tools. Because tools are just tools, and honestly, it's true, 95% of the work is really data acquisition and data cleaning. So I went out there to websites and wrote web scrapers, automated everything, collected a bunch of data, and then I had so many different data sets, I had to combine them somehow, and I wrote tools to automate that, and then I had to run regression analysis to find interesting patterns in the data. And the challenge is also you have a budget when you buy your players. You can't just buy the best players, would be too easy. So you want to find the optimal combination of that. And these are just field positions, like defender, midfielder. So you had to put constraints on that. And it was just a fun project, but it helped me a lot because I was interested in it and I really learned the tools. I went to blogs, read about certain tools, found something that helped me, wrote my web scrapers. That was really great. It was a lot of fun. And yeah, another thing, maybe a simpler project, I was working on maybe 3 years ago or so, or maybe 2, 3 years. I built a song mood classifier. So here, how this worked basically, I had some songs. I got this from the Million Song data set, and I labeled them, whether they are happy or not. I really literally went to YouTube and listened to, forgot maybe 1,000 songs. I listened to them and labeled them happy or sad. And then I also downloaded the lyrics, and then I had the question, okay, can I somehow automate this prediction? Can an algorithm automatically tell me if this song is happy or sad? And I thought, I mean, it was more like a toy project, but I thought, I mean, if you take this further, you can say it can be used in hospitals to cheer people up, to have an automatic system that only plays happy songs or things like that. And yeah, and also made ultimately a web app out of it that you can put in the songs there and things like that. And during, I mean, because it's data science, the exploration stage, I found interesting patterns, for example. Why so sad, the mood of music over the last 50 years. For example, I found that back then in the 60s or 70s, what a surprise, music was happier. I didn't know this before. I found this out by really labeling them. I was unbiased and hopes a little bit subjective maybe, but really based on the songs. And then I later did these plots. I was really surprised that we are getting so depressed these days. But yeah, like maybe college is too hard now. But yeah, it's just one example, an application of a hobby project that helped me really learn. In this project, I especially learned how to build this web app. For example, I never had any clue how to build a web app. Well, it was pretty exciting. Yeah, and these are some academic projects. It was just from a paper that we published, or we just got accepted last week. So in this project, for example, I'm trying to predict how a ligand, for example, this yellow thing there, binds into a protein binding pocket. And we had a novel idea. Here, Joe was also, he's a researcher in our lab, and student and researcher, and he did also a great deal of work there, really great. So he collected 30 proteins, and we worked together to come up with an algorithm based on graph theory to predict how a ligand can bind into this binding pocket. And we got pretty good results. So what it is all about, you can sample this yellow ligand in different conformations, but how do you know if it's correct or not? And this algorithm basically, based on how rigid this blue part becomes, the more rigid it is, the more natural the pose is, the yellow one. Just one example. And another research project, I'm currently writing up the paper, was a multi-year project because I was collaborating with a lot of experimental biologists. You don't have to read all of this, but I'll just say this virtual screening application can be used for drug discovery. What we are doing is, based on a molecule, we want to find similar molecules that can have a certain biological effect. And it's basically a pipeline, and it involves, we have 15 million molecules, and each molecule, so you have 15 million molecules and you're looking for the needle in the haystack. So our collaborators, they are interested in maybe 100 molecules. They have an experimental lab setup, and they can only test 100 or 200 molecules. I mean, it's a lot of work. And but if you have 50 million molecules, which ones should they test? So you really have to make some certain prediction to narrow it down for them. And if you think about it, each molecule, if I take a structure of a molecule, it looks like it's a flat thing, but in real life it's a flexible thing and can rotate and things like that. So you have to also account for that. And then you can basically multiply your database of 50 million molecules by, let's say, 200 if you sample 200 poses. And that is a real challenge, not for like your accuracy, like building an accurate classifier or model, but also how to handle so much data. So here I used, for example, the HPCC and different database technologies like SQL and HDF5 to store this data efficiently. It was another great project to learn new skills. And also the problem is our collaborators, they can only test these substances because they do experiments on fish. And the fish has to be in a certain mating stage. They can only do this in May or April. So, and during the other time, half of the year, I have to work on different projects. So it's usually time sensitive. You have to do this fast. And yeah, that is also, I think, how you learn new things by getting challenged by different aspects. it's not always about building the most accurate model, but it also has to be feasible, understandable, and sometimes it's also time sensitive, cost sensitive. I mean, there's this famous example. Have you heard of the Netflix prize? Yeah, the Netflix prize, you know Kaggle? So Kaggle is a platform where you can compete against other people building machine learning models. So companies go on Kaggle and they pose a problem there. For example, Netflix said, hey, the one that builds the best recommendation engine for us gets $1 million, literally $1 million. And people have a public leaderboard, maybe 1 or 2 months time to build predictive models, and the best player or researcher wins the $1 million. And eventually they didn't use the best solution because it was way too complex. It has been maybe 5 years ago, but as far as I can remember, it was a stacking classifier or multiple stacked classifiers, and it was a really complex model. And Netflix says, okay, that's cool, but it's way too much effort to implement this efficiently.